will be by Reem Livy from Message Point, and she will talk about universal content ingestion.
But first, let's espouse some corporate propaganda. I don't get it.
Yeah, okay,
So,
really small.
But more, of course, we're hiring. Come to us, work for us. But related to this, so I mean, the content ingestion talk. Part of what we're pivoting into is content intelligence platform, which is a new category that we're trying to define, which effectively we're moving into a space. A lot of people are looking at understanding content, right? Semantically understanding content, syntactically understanding content. We're looking increasingly at taking the same concepts and understanding the document itself, right? So everybody's on what's in your content. What does it mean having the machine understand content as a person would understand a content? This discussion, a lot of what we're working on is, let's take that concept and extend that to the entire context. Right? Let's take that to the document, let's take it to the form, take it to digital, whatever it is. That's the space that we're trying to play in. So that interests you, and corporate propaganda can work for us.
Thanks, Matt. He's Matt, not Reem.
That's right.
So, hello everyone. I'm Reem. That was a really nice introduction to what we're going to talk about, because what we face at Message Point, having to work with large volumes of documents, all in different formats, is having to deal with all of those different formats. So as data scientists, we're required to, or our responsibility is to extract high quality content from that kind of noisy data. The problem is, when you're working with documents that have different formats, then you have to, it becomes costly to maintain and manage that kind of corpus. So at Message Point, we solved this issue by, through a concept that we call universal content ingestion. So today I will describe the problem with document formats, and then we'll talk more about the universal content ingestion concept and talk about how that applies into creating a unified document model, and then we go further and see how that opens up new opportunities for us for higher level analysis and for better, deeper insights, actionable insights into our content. And as one example of what we are trying to do, I will be talking about our font recognition application. So as I said, working with a lot of formats can be costly. The more documents you have, the larger your corpus, you likely have even more formats. That means you need more experts to deal with those formats. It means you need more time to work to manage that data. It'll also mean it will be more expensive, which will add up to an increasing cost in all different aspects. So our solution is based on the idea that in a document, what you see conveys a lot more information than just the simple text content of the document. So here's an example. Even without being able to read this document, unless you have laser vision, you probably know what kind of a document it is. Want to guess? A letter, exactly. If I give you another document that has the exact same text content, I promise, you still won't be able to read it. Would you have ever been able to figure out that this is a letter as opposed to this? No. But why? The previous talk should probably give you a hint. Like, when you take out all of those visual aspects in a document, all of those different things, all of that information, you really lose a lot of, what are they called? Attentive attributes, right? So documents contain more than just text. There is the text of that letter, but then one of the things that you can see in it are those contiguous blocks. There's a reason why they're all together. So those blocks are the conceptual blocks, and the way they're laid out, that pattern also tells you something about the document. If I were to blur everything and just keep the blocks, you probably would have guessed a letter. On top of that, those blocks are also related in where they are. The address block comes before, the sender's information usually comes before the recipient. The recipient comes before the body of the document, and so on, or the body of the letter, and so on. If you have any questions, by the way, at any point, just let me know. On top of this, there are the visual aspects we talked about. Typefaces, like what type of, we call it font normally, but the official name is typeface, like Arial and other kind of typeface. Styles, is it bold, is it italic? The size of the font, the color combinations that you use. All of those are part of your message in the document. So our solution, we call it universal ingestion. The idea is to use all of that kind of information to build a unified document model. So, you give me any kind of document, any format. I start by converting it into the one common denominator format that all documents can have, which is an image. I start with that image, but that's not my document model. That's just my starting point. So I start from there, and I build on it. I start by identifying my blocks, my conceptual blocks. I'm still not looking into those blocks, but just from the way they're organized, I know there is something there. So that's my first layer in the model after the document image. Then, just from where they are, I can also create relations between them. Something like this block usually comes before this block. If you have a header, you also know where it will come. If you have a footer, without knowing what's in it, you know that the header is at the top, the footer is at the bottom, and so on. And then you can go further and look for even higher analysis and look inside of your blocks. Now you can start doing something at a higher level. Something like semantically tagging all of your blocks. You know that this is the information of the person that sent this letter. This is the sender information. I have a pointer, but anyways, this is better pointer. This is your sender information. This is the recipient, the body of the letter. And even there, you can start and creating relations between them. So as you can see, starting from the PDF or Word document, we are starting to create a more unified model that is very rich, that will allow us to create more and more relations and observations while retaining those features and that information in the model. Yeah?
That will apply only for letters. For example, if you have
Go ahead.
yeah, if you have a CV or I know, a letter to my mom, can you do the same?
Absolutely, because you can still, in a CV, you can still see those conceptual blocks in that document. You can still see where the name is. Imagine you get that resume, and then you blur out the words, the lines. You replace the characters by circles. Then you'll be able to see all of those contiguous blocks in your document.
Yeah,
of course, some documents, like a letter, are going to have, and statements, bank statements, are going to have more blocks in them than maybe a legal document. But still, you can still apply all of those relations. You can still create all of those conceptual blocks. You can even go further into, for some of them, you might want to go further into a block and then divide it up into further blocks, maybe paragraphs within a legal document, and then look at relations between those.
Then I need to know that all of the different formats belong to a legal document? I mean, do I need to classify them before doing all the analysis?
You can, but we're hoping you don't need to. So the way we're working is that you just by identifying those blocks and then starting to go further and look for more and more relations, you will be able to figure out which document you have. Yeah.
Sounds a bit to me like this is the analysis of a document analog to the document object model in an HTML page.
Yes.
It's the flip of that, taking the document and turning it into the model as opposed to taking the model and turning it into the page.
Yeah. And yeah, the goal here is to have everything represented with that same in that same way, so that we don't have to worry about how it's.
Which is what happens in HTML.
Yeah, which would be nice to convert it, like PDF and all of the other formats. Yeah.
Yeah, how many annotated training samples do you need for each category?
How many?
Annotated training samples.
Oh, annotated training samples. So for it depends on what we're doing. If we're doing deep learning approach, then we definitely would need more than if it's just based on the visual image processing techniques, which are sometimes possible. But with deep learning, you can also reduce your requirements by using transfer learning. And it's interestingly enough, as you'll see, we've used for font recognition, our model was pre-trained on ImageNet, which has nothing to do with character.
Very quickly, the basic building blocks are discovered through visual elements only. There's no classification there, right? So you're literally looking at objects, the color objects and the saturations and color differences.
Yeah.
And you're doing clustering around those.
Yeah, for those tasks, I suspect that the requirement should be very low. Doesn't require much samples for the task.
Yes.
Yeah,
but
those are almost out of the box.
Yeah.
Yeah, if I was try to look into it for say what's the amount of the money I inside, there is a detailed concept inside the block.
So the semantic labels that we mentioned, those are classification objects now. So they get trained, the classifiers get trained by showing examples. Some of them get picked up by language models that we have.
Yes.
So some of them are more sophisticated than that.
So that's where you would need sometimes the deep learning.
Yeah.
Okay. So through that unified document model, we managed to keep and retain the visual features, layout information, and text information. From that point on, we can start to do a higher level analysis on the document itself. So through our visual features, because we kept those there, we can do brand identity verification, for example. To identify the brand identity of a corporation, you need to look at the color schemes used, the fonts, the types of fonts, the styles, where they're being used, the placement of the different components of the document. All of that is now still possible through that unified document model. You can also do document type classification, as I showed you. I mean, a letter looks like a letter. So that's another example of how this helps you. And font recognition is part of different things that you can do, one of which is brand identity verification. And later, we will go into how we do font recognition on documents for that reason. Another type of information that we have retained is layout information. Because we have that information, as I said, you can figure out where the where the headers are, where the footers are, your margins, and so on. You can look through a full corpus of corporate documents, and then make sure that the use of those headers is consistent, and those margins and footers and any other components in terms of layout. Then you can go into the text, and that's what we have usually from a document, the text content. That's the first thing that comes to mind. We can do topic modeling, which is trying to figure out what the main topics are, and you can do that by looking at the body of the document. If you have a letter, you have other pieces of information. If one of your blocks is the subject line, you know this is a main topic, for example. You can also do semantic tagging, like I mentioned, where you can have the recipient block from which you can figure out the recipient's name, the signatory's information at the bottom of the letter if it's signed by someone. You can even go further because you have the sender's information at the top and the signatory's information at the bottom. You can now figure out the address of the person who sent it. So that's how you can, that model allows you to create relations that you could have lost in a plain text. Semantic similarity across components, you can do, if for example you have a corpus and you're trying to compare two different documents, you won't take the address box and then compare it to the body of another letter, because you know these are semantically different. So that allows you to do smarter semantic searches, smarter semantic similarity comparisons. So we've seen how we managed to take the raw data in the form of the different documents in different formats, convert it into a unified content representation, and then how we could carry that out to, or use that to create higher level analysis. We can go even further. Now we can have a whole corpus of documents that are represented that way, and we can have actionable insights. For example, I could have a whole data set of those documents, and I say, show me all of the correspondence that we sent to client A. Or maybe I don't care about the certain type of the document. It's not just correspondence. I want all the documents, but those that talk about a specific topic, like funding proposals. I could also go and say, show me all of the letters that were signed by this person. And you could use that further, maybe to verify their signature that is consistent. Or maybe you can use it for fraud detection. So from that unified model, that one representation, now it opens up possibilities of doing a lot of different operations on multiple levels, document level, and as well as a whole database level, or data set. So now we go back, as I mentioned, one of the things that we can do now is identity, brand identity verification, for which the types of fonts or font recognition is one part of that. So we'll go into a bit more detail of how we do font recognition. So of course, font recognition uses the visual features of the document because it's how those characters look like. The idea is to take a document in any format, convert it to the unified model, and which includes the image of the document. Then we feed pieces of that document into our font classifier, and then it will tell us which letters or which fonts were used, what styles, which typefaces, and where. That will allow us to go back and verify that the document actually does adhere to our identity branding rules. Font recognition, the problem itself is just generally defined as a multi-label classification problem. At least that's the kind of definition we follow, which means that if you have an image, you can classify that image with any number of labels at the same time. You're not required to pick one. So if I have an image of a character, I want to classify that character with any number of styles that apply and with the font that applies. Hopefully I'll end up choosing one font, but it could say, it looks like any one of those fonts. There have been many different ways that people have proposed, like base classifiers, k-meter neighbor, support vector machines, and the older backpropagation neural networks. But of course, now recently, a lot of people are trying the deep neural networks. So some examples of the neural networks that have been used are, as you can see, VGG16, Inception, V3, AlexNet, ResNet, and DenseNet. Because ResNet and DenseNet were found to be among the most effective, we've chosen to work with ResNet 1. The nice thing about deep neural networks is that they are easily extendable to larger numbers of fonts, which is something you want in an organization where you will always have more documents coming in. Your document volume, your corpus, will always increase in size. So you want to be able to retrain it, and you want it to be expandable without huge cost to the content. So we're using Amazon SageMaker's ResNet 50. In my preliminary experiments, I've tried the deeper models, like ResNet 152, and it really didn't seem like it was giving us anything. So there was no point in using a more complex model. As I mentioned before, we use the model that's been pre-trained on ImageNet, and we define the fonts that we use are those Arial, Helvetica, Courier, Vera, and Times. The styles are either regular or any combination of italic and bold. And if you look at ImageNet, it's not where I want it. These are the images that the model was trained on, pre-trained on, before we fine-tuned it for characters. It's very interesting to see that something like this actually helped train it for font recognition. In a paper that used ResNet, I think it was a deeper model, I can't remember right now, they did not use a pre-trained model. They ended up having to run it 10 times longer than we did.
Did you have underground explanation for that phenomenon?
Yeah. So the earlier parts of a deep neural network start by working on identifying the edges and the curves that are important in your input, in your images. And those are the same things that matter in identifying the typeface of a document, of a font or a typeface character. Okay, so we start with that model. It's pre-trained. The next thing we need to do is to fine-tune it for characters. Now, we need to train it on a character, a data set of characters that have been pre-set with a variety of fonts. So for that, we created a character-based font recognition data set, where we started off with documents with which it's a synthetic data set. So we created those documents. The fonts and the styles, the typefaces of the characters were known. We picked character images, extracted character images from those documents, and that created our character-based font recognition data set. And these are examples of the character images we have. As you can see, they're not those clean one character per image kind of thing, but this is good because that noise allows our deep neural network to learn even though there is noise. And that's the kind of input that it will get from the test and real-life documents. So our data set contains about 9,000 character images. I've already mentioned the typefaces and styles used. The characters are, the images represent 80 characters, each of which is represented in each of the 20 typeface and style combinations in different font sizes. this is how the ResNet 50 model looks like. Basically, you take the character image, it goes through each one of those layers. As it goes in, the image size changes, and the kinds of details that it learns changes. Those, I'm being very general here. Those are called skip connections. These are basically what really made ResNet very successful and much more successful over its predecessors. It's still, that concept is still important now. This is another skip connection, but with a little twist, just regarding the size of the input. It's nothing really that important here. So you take the character image, it goes through the model. Once it's trained, hopefully it will give you that kind of list. This kind of the list where it gives you the list of possible labels, all possible labels, and with each one, the model, the network is telling you how confident it is that this label is associated with the image. Yeah.
So what's a skip connection?
So a skip connection basically, I went into a bit too much detail here. So a skip connection basically brings that input and carries it over here and adds it to, like, so you have your image, you do some operations on it, and then you take your image through the skip connection and you combine the two results, the two things, your actual image and the image after processing.
So you're making a copy of it?
Yes, exactly. The idea is it will always give you some minimum optimal result no matter what happens, which previous models couldn't do. They just basically gave you nothing if you tried to make a deeper network. Okay? So this is the output. All of the labels, each is associated with the network's confidence that it's relevant, that label is relevant to the input image. To train the network, we took our character data set and split it into training, validation, and testing with these ratios: 70% for training, 20% for validation, 10% for testing, which came out to about 6,000 character images for training and 2,000 for validation. For our hyperparameters, we ran it for up to 100, allowed it to run for up to 100 epochs, but because we used early stopping, it actually ran for about 25, 30 epochs for those of you who are familiar with neural networks. And the one important thing here is that we used weighted cross-entropy loss, which because of the kind of combinations that we have for class labels, for typefaces and styles, we have a class imbalance. So some font, there's a lot of bold characters and less characters for example, the Arial font. Because bold, there is Arial bold, there is Helvetica bold, there is Courier bold. So that will create a class imbalance, and with that you usually use weighted cross-entropy loss, which takes care of that. And then we tested it on about 900 character images, and our predictions came out. So the prediction from the output, we took all of those labels that the network was highly confident in. So our definition of high confidence is that it's higher than, the confidence is higher than 0.8. And for other networks, for other tasks, it might be less, but for us, this is what worked for this network, because it was so effective in classifying those characters. So now what we have is, we have our font classifier. You give it the image of a character. It gives you a list with confidences, And from that, we pick all of those that it's confident about, and that gives you the font and the styles that are applicable to your character image. The results of those tests show that the classifier works really well, over 95% for precision, accuracy, and recall. And basically, let me show you precision. So precision is, TP is true positives for if someone hasn't worked with it yet. False positives is FP, and true negatives, false negatives. So the P and the N is positive and negative, true and false. Okay? So precision basically gives you the ratio of everything that was labeled as, that was given a label. How often was it right? That's how precise is your classifier. Recall of everything that it could have labeled, how much did it give you? And accuracy is how accurate is it? When it said this was this label, how often was that correct? Okay? So you can see here that everything works well except for these two. They're okay, but they're not as good as the others. Now, if you look at the characters for the Arial and Helvetica fonts, you can probably start to guess why. The characters are extremely similar for the two fonts. And the hypothesis here is that this is why the network could not distinguish between the two. If that is true, then if I were to look at all of the Arial characters that were misclassified, most of them are going to be classified as Helvetica, and the opposite for Helvetica. And true enough, if you look at all of the white chart, if you look at all of the character images that were misclassified, that were actually Arial but misclassified, 70% of them were Helvetica, were mislabeled as Helvetica characters. And the next one is Vera. Vera seems to have some similarity as well, but it still performed okay. And for Helvetica, it was the other way around. 77% of misclassified Helvetica characters were mislabeled as Arial. Yeah?
So this is for a single character, right?
Yes.
So consider your scenarios. You are looking at a block. Will that help if you look at the multiple letters at the same time?
Good question. Yeah. So once you have that classifier, you can start now and look at your document. And I actually did build a Lambda function and a script that will take in a document, convert it, and then send it to that Lambda function, which will start separating the characters. It will send those characters to the font classifier, and it will give you back whichever you want. Like if you want a tally account of how much of a certain font you found, or you could just say, give me a classification of every single character, you can do that. So your unit here is the character. You take the document, divide it up into characters, and send the images off. You'll get your classifications.
Are you asking if you learn from words, would you learn better?
Yeah.
Not
because
yet.
they accurate.
Oh, that's
They
what you're
boost each
asking?
other. They are boosting
Yes.
each other. Yeah.
So we're working on it.
Yeah.
Oh, great.
So actually you're leading to something weird I'm going to mention later. There it is. So yes, one way of, of course, to be able to distinguish the similar fonts better, or typefaces better, there are several different standard ways. Augmentation, bigger data set, and so on, a different model. But one thing could be to change the unit that we're using from the individual characters into something bigger. It could be full words, or it could even be patches of documents. That will give you more data points within a single image, which might allow, we're expecting it will allow, the classifier, the model, to learn better how to distinguish between different or similar characters or similar typefaces. Yeah.
One thing I noticed, maybe it's just me, but one of the fonts was slightly narrower than the other. Maybe that could be an attribute that you could use.
It could be, but we expect the model itself, the network, to learn that on its own.
So when it comes to fonts, right, there's a lot of font-specific attributes that you can potentially use, like how much distance from the top, and where. So we didn't take any of those into account, right? Because this is if we can generalize it well out of the box, why not, right? But you're absolutely right. You can potentially use those as well.
Yes, the idea is to try and keep our distance as much as possible from what is needed, because as fonts change, as your collection changes, you're going to need to retrain them, and you really don't want to have to mess with it again and try to measure things again. Yeah.
It's obvious to me that this is required if you're working with paper documents because you get nothing else to work with. Are you incorporating the metadata in electronic documents to define, so you don't have to go through all this route?
Sometimes the problem is if, like you can, the problem is if you have many different formats, then you will go back to your square one where you need experts to start extracting that kind of data from each type of format. So we are trying to show that this is not needed, that you can actually, in the end, you will.
Just from the image.
Exactly, that you can actually build that model for whatever you give me, I'll build that same model, and once I do, that means I'm ready to use it for all of the stuff that I've already done in the past.
PDFs or Word.
Exactly.
There's this vulgarity in electronic documents called PDFs. You can get anything from an image, which looks like a document, to like content
Yes.
that's like has all the metadata in it, right? So then how do you figure out like how to work with PDFs? It's a very generic. This gets you a lot further.
Yeah.
Is there any cross-validation?
Yes. So the validation, there was first the validation that was done as the models were built, and then we did cross-validation. We did threefold cross-validation just because we felt it was it just proved the point with it. Yeah.
How does your model accuracy compare to humans?
I'm not sure, but I mean 95 to 100%. Hopefully that's close enough. But I haven't compared it straight like with humans. Like we haven't had human testers show it. I think actually it's not even 95. It's around 98% accuracy that we have now from this classifier. So for practical reasons, this is starting to be a good usable application.
Do you suspect it'll be lower with humans? Is that
No, I was just noticing the Helvetica versus Ariel.
Yeah.
Would humans do better on this
Yes.
task?
So
Yeah,
we
for that
have-
specific one, probably.
We have in our company content people who literally like can look at two letters and point me to differences
Yeah.
because those are experts.
Right.
The problem is those experts are not in high frequency. They're not available in high frequency, right? And if you're working on projects that require that expertise, there's no way for me to say take that expert and have him work on 4 different projects at the same time. This allows you to do that.
So
Even if you're comparable, that this gets you.
So hopefully with more work on the model, we will be able to raise the Helvetica and Ariel ones to as high as the other documents. So again, going back to our unified document model, now as someone mentioned, we can go back and look into the blocks themselves, and we can start and look at the individual fonts used within a block, and that will allow you to say, okay, in an address block, these are the fonts you use in our brand, and the first line has to be bold, the rest don't, and so on. You can even go through a whole corpus and verify that this is actually what's going on and catch any mistakes. Yeah.
It seems to me that could also be used for brand performance analysis as opposed to content analysis.
Yeah.
Keen observation.
So, We've shown how we solve the problem of document management using the universal ingestion model. We introduced the unified enriched document model based on that concept, and we presented examples of higher level analysis and how to use that for actionable items using this model.
I have a question. So you built this model, I suppose, on English. Will this work different on French words or on non-Latin based words?
I haven't tried it in French. Definitely it is tunable for non-Latin. French will probably be very close to English, but I haven't tested it on that. Definitely that's something, if we want, or as we go closer to production, that's something we will build in.
Accents?
Sorry?
Accented characters?
Yeah, everything. We should.
So Reem and I have had discussions around, for example, languages like Arabic, where a single character, depending on where it appears in the word, can change its form, right? So that becomes, and I'm not sure if it's problematic or would it give me more signal, right? This is something that we're looking into at some point, but go ahead.
Yeah. No, I was gonna say that I've seen papers that
There's
work
literature
with
for that,
characters,
yeah.
so from past work, it's most likely going to work just as well.
And another problem with Arabic is the character boundaries aren't clear.
Yes.
Yep.
Yes.
And sometimes they're not clearly separated. Other questions? Well, I hope that means everything is very clear.
Thank you very much for coming tonight. Also, for the people who haven't joined our Slack space yet, you're welcome to join our Slack space. And always, if you want to talk in the future, just easiest way is to shoot me a message on Slack or otherwise on LinkedIn, and then we will work further from there. And thank you very much, Apply for hosting us.